Hello, in this video I will talk about deleting from the tail in a linked list. In the last video we deleted a node from the head. Now we will delete from the tail. So deleting from the tail is more complex than the deleting from the head. Deleting from head takes constant time. However, deleting from the tail takes linear time. So let me explain in here. Okay, so um, when you delete from the tail, uh, so we know where the tail is, so we can access to the tail in constant time. However, in order to delete this one, we need to find out the predecessor of the tail. Because we need to update the tail, so we need to know what comes just before the tail. So to do this, we have a temporary variable, temp. So remember, we should not modify head. Head should point to the first item always. So we have temp. So we move the temp to the next one. Now temp is here. And then we move the temp to here. We go all the way to the predecessor of the tail. So how do we check? If we try to go to the tail, we could say, is the temp tail? Is the temp tail? Okay, we could just ask this question. However, if temp comes to the tail, it is too late. We wouldn't know what comes before the temp. So before reaching to the tail, we should say, is the next one tail? Instead of saying, is the temp tail, we say, is the next of the temp tail. Once we know that the next of the tail, next of the temp is tail, then we stop right there, and then we say, okay, temp is here, just the predecessor of the tail. And now we know that temp is here. We point to tail from here to here. Okay, now this is not tail anymore. We should just free this. Okay, so we free this one, and there is one more operation. The tail, the next of the tail, should be null. Right now it is not null, so we make it null. Okay, now let's write the code. Okay, so we can keep that also void. Okay, and then delete from tail. The parameter is pointer to the list. Okay, pointer to list, and the same idea. We should have a. By the way, first of all, we need to check if the list is empty or not. Okay, so let's do this. So let me just make a change right now. So instead of checking not empty, I will say if list is empty. So if I say if head is null, which means it is empty. So I can just display a message to the user. List is empty. Cannot delete. Okay. Otherwise, else. Now that means the head is pointing to somewhere. Okay. Okay. So for so here we need to the same idea as you see here. We have a temporary variable. I will do the same thing for this. Okay. So here let's say a node. Okay. Okay, so a node pointer. Okay, so let me explain in here. I have, okay, so I need actually in here, I need two local variables. One of them is the local variable which should point to tail, because at the end I will free it. Okay, so as you see here, I updated tail, but I need to have a variable to free this one. So let me just name this temp tail. Okay, temp tail. Okay, and then I will say because I know that the list is not empty, I can just take the tail of the list and assign to this temp tail. Okay, and after I do this, I should check to see if there is only one node in the list. If there is only one node, I should just make both head and tail null. Okay, so here, how can I check that there is only one node? If head and tail are the same, that means there is only one node. Okay, so here, if head and tail, so list head equals to list tail. Okay, if that is the case, I say make both of them null. So make the head and also make the tail null. Okay, else, okay, so else means there is more than one node. So when there is more than one node, so head and tail are different. So that means the tail has a predecessor. Okay, so for this one, I need a loop that goes from the start and goes all the way to the end. So for this one, I need another local variable. So let me explain here. I need this temp, okay, and then it starts from head and it goes all the way to the not to the tail, just before the tail. Okay, so now let's go back to code. Okay, so here I need another another pointer. Okay, so node, and for this one, let me just name this temp. Okay, temp, and also I can just say I start from the head. Okay, so here I say, okay, so list head, start from the head. Okay, and then I have a while loop. Okay, the condition is I should not say if temp is tail. I should say if next of the temp, if the next of the temp is tail, I say okay, stop here, do not continue anymore. Okay, so I say so okay, if it is not tail, I should say okay, keep going. Okay, so here if the next of the temp is not tail, list tail, just keep going. Okay, and here I should just move to the next one. Temp equals temp next. Okay, so here I after this while loop, temp is pointing to the predecessor of the tail. Okay, so here let's look at the picture, what we do. So here tail, we updated tail. Now tail is pointing to here. It is okay because I stored the location of the tail in a temporary variable. Okay, so as you see here, I did that. so I can just free this one later. So first of all, let me update the tail. So I say make the tail whatever the predecessor is. The predecessor is temp, so just update it temp. Okay, the other one is so I should cut this connection. So the new tail is pointing to old tail, so I will make it that it will not point anymore. So I will make this part null. Okay, so here I say okay, so make the tail. Okay, so tail and next of the tail. Okay, make the next of the tail null. We are not done yet. We should free the old tail. We should free this old tail. So here I say free. Okay, and what is it? Temp tail. Temp tail. Have we forgotten anything? Okay, semicolon here. What else? Okay, so it seems correct. So let's see how this works. So delete from head. Now let's delete from tail. So if I do this, we have D at the tail. So let's see if we are deleting D. Let me run it. Okay, it worked. It deleted D. So what if the list was empty at the beginning? Will it still work? So now let me run it. Okay, it worked successfully. It says list is empty, cannot delete. Okay, I hope this is clear. Have a nice day.